today we are going to learn one more important thing. Yesterday I forgot to, so this is the second episode on Jmockit, and we were successful in implementing Jmockit for calculator method, and we had used state-based choice for Jmockit for testing the method because the states are very clear here. But as you know that the Jmockit can be tested using we can test not only using new expectations, but also you can use what do you say as mockitup. So we will try this a second expectation where we try to use another test where we are going to use mockitup. So what I meant by the third test is very simple. I'm going to use this. What's the reason? So now we have methods here instead of expectations. We have something known as mockup, and the mockup calculator. I'm using the class type here, and lag methods, and maybe return 999. It's again state behavior, and I can multiply it and return. So let's try to return the same one. Maybe returning from expectations. Expectations we are returning any values here, right? In date quantity, I'm returning 999, and in A into B, I'm returning. So now, what exactly happens here? Is a very important point to note here is that assert equals test real calculator. We need to do one more test here, and the test what we're going to do is that this test simple marking with expectation test with real calculator, and now we have I'm sorry, change it. Now what I'm going to do here is that I'm going to put my test here, and then I'm going to enter once again, and then when I say add test, I need to close this. My test is here. So this is the way you can use new mockup, and then I need to add test, new mockup. Why is this giving me a problem? In a body to complete blocks, it just cannot be resolved time. So now we see that I wrote the state identification or state definition in marking, and I use mockup. So you have to remember to use mockup. You have to use import segments, import mockit, o.mock, and import mockit.mockup. So I use mockup here, and I say I'm going to mock this method using the mock annotation. I'm going to return 99999, and I'm going to mock this one, and I'm going to return 888. Now let's run this test and find out if it works, right? So I'm going to clean this, run this, and then what exactly happens is that when I run the maven test, so the test ran. So we have not done any assertion, but in our first method we had done assertion when we use expectations. So let's use an assert here just to verify. Let's do this. So can I do this? So when I do this and I take the result, I'm going to call the math service here, right? And I have to call a calculator also. So when I call math service to perform calculations, I need to call the specific method. So let's try to do this exactly like this. Now I'm passing this int result, and then what I'm doing is that math service is not defined here. So I'm going to have a math service also here. And put it here. So math service is equal to new math service. It needs the calculator to pass. So I need my calculator here. And then my calculator. So let's name this my calculator as my calculator for mockup. Okay. No, this you will not do here. Now next is calculator. My calculator is a new calculator. Then I don't need this assert right now to verify. I'm verifying this afterwards. And now that means that I'm totally prepared for all this. My calculator mockup is here. So it's the same. This is returning 999. So multiplied is 888. Now what I'm doing here is I had only one assert statement here in this one, and that assert should be I'm doing a result. I'm taking perform calculation. Perform calculation does, as we remember that it does only addition, right? So perform calculations, in that you will have both add and multiply. So in the markup, what I'm doing is I'm doing an add here, it returns 999, and then I'm doing multiply, it returns 888. So how do I assert this? That's the question. So let's come back to assertion now. I have to do assertion here. So what will I do? I'm getting a result by math service dot perform calculation. You have to remember for mockup, the way we do assertion is different. We actually call the mocked methods. So this is not needed. What we need is assert. This is returning 999. So I'm going to say 999. Here's the catch now. Here it's a bit different. Here I'm going to say I'm going to call calculator dot add. And this is now again, since I have an instance of this, I can call this one my calculator mockup. So this is what it does, my calculator dot add. And we have to close this by braces. You don't need this one, as far as I know. But let's see what is the syntax saying here. It says to me that syntax have to complete this token. So it doesn't want this token, which is fine. Now what else? The method is undefined. Process. As always, I look forward to guiding you through all of these topics. It could be math service. This course. The 2025 BA exam, usually known as the special enrollment examination or SEP, is based on the 2024 tax law. Specifically, it is based on the law of December 31st. Another question comes is, do I need to use math service or I can use my calculator mockup or type one? This is telling me that assert equals is non-defined for simple type Jmockit J. But let's try this now. So now I did assert for my calculator mock.add. It can take any calculator means it can take a calculator class. I'm doing an add. After I do add 1, 2, it returns 99 because this method returns 99. So I'm doing one assert. So I can do another assert using multiply. I'll not do that just for the result. I'm going to run this test and see if it works. So let's do one thing else then. Clean this and run the test once again. Now let's run this test. Yep. The test ran, it's working, the assertion is working. So now I conclude the 3 ways of testing, right? When states are identifiable, you can use without mocking and just test it. You can use mocking, but since you use Jmockit, we're using expectations. In the expectations, you actually pass the instance and then test it. And then you don't need this. So I'm going to remove this because I'm only testing the method, not the service. And then I'm going to call mockup. So you have to remember that mockup doesn't take up an instance, it takes a type of class. And you better mention that you can leave it empty, but if you leave it empty, you'll get class cast errors. Let's go to the POM, which I wanted to discuss a bit, but let's first run this. And when we run this, we are preparing a report here. Now I see something which is a compilation error. We need to see what was the compilation. We have some result, and I had this issue of taking the result. Assert equals 10. My apologies, I should not have taken out this. So math service.perform collection goes 2, 3, and I get a result, and then it is asserting with that result. So I could have done the same thing here at the bottom also. I'm not doing that. I'm testing only the calculator class here, just for simplicity's sake. So that being said, let's try to run this. Run as main, run as main test. Now, we have to remember one thing is that when you run Jmockit, how actually Jmockit works. So Jmockit works with the principle of, I think the instrumentation inside the classes. What exactly I mean by that? That's very important to understand. So now let's come back to what I was explaining us. When we use Jmockit, we have to attach an agent to, see the instrumentation of Java code, is bytecode, because we need to see that when we are running a Jmockit test, how much code is covered. I mean, my class, which I use calculator.java, I need to see how much of this calculator class I have covered, So behind the line, I am making some surefire reports here. So let's see those. Try to open them. Target, and then you have the surefire reports here. So let's open this. And then you have something known as simple Jmockit test.xml. So this is very important data because some of the tools like Sonar and all, they use this XML to see how much the code got covered, when you were running the tests. So that is the purpose of, having the surefire reports to cover how much code has been covered. So here I have used Jmockit in my form file, but Jmockit is what? Basically, in its nature, it is something which is attaching as an agent during runtime. So what I'm doing is I have a maven surefire plugin, and then I'm pointing a Jmockit jar, which I'm attaching an argument line when I start the surefire. So when we start running the Junit test, who concludes that the Junit tests are at source main test? That's an important question we should ask. Because what we do is that we come here, and then we always put our code here under source test Java. But who is actually picking those tests when we run maven? What's the mechanism? Most of the times we don't know that what's the mechanism. So what exactly happens is that as soon as this code is picked up running JUnits, of course, JUnit, which recognizes where JUnit has to be recognized. And then on top of that, since it's a library JUnit, you see it's a dependency. On top of that, we say scope as test, right? So when we say scope as test, it has to pick up the code from source test Java. So right now, when I'm running JUnits, I am indicating that I have JUnit 4 tests. So as soon as the code is compiled and built, code, or when I trigger testing, the JUnit 4 automatically picks up the code from source test Java. And then as soon as the testing is done, the surefire reports plugin kick in to fire the reports of the test. And that's why we saw XML5, which is again used by tools like Sonar. If I indicate that my test is JUnit 5, not JUnit 4, or maybe my test may not get picked up. So I need to make sure that before I start testing in JUnit, I need to do some kind of markup of which all code is being called during testing. But that markup I cannot do in my code. During coding or compilation time, right? I have to do it during bytecode time. So I need to make sure that I need to intercept when the bytecode is running. then I need to do that marking of or instrumentation of the code, which I'm going to mark for covering. And as soon as the test is going to start, uh, the the surefire report will get triggered as soon as testing is complete. And then I have to see how much it is covered. For that, I need to restore that instrumentation as soon as I will take out first instrumentation. I'll tell you why we have to take out. And testing happens and I have to restore the instrumentation. Then I'll come to know what is the coverage. So for that, you need to have something like instrumentation in Java. So let's try to see what is instrumentation in Java, right? So let's go back to node. So what you see is that a piece of code which will do some changes while the bytecode is running. It's again a piece of Java code. It's a Java file, and what it does is we want it to make changes when the bytecode is running. So we call it an agent, Java agent, which we execute exactly on demand or when starting. So when we do it on demand, we call it dynamic agent. And when we do during the startup, we call it static agent. So this agent, dynamic agent bytecode, is getting executed at a certain point. That I just hooks. And class loader is the one which loads all your class, right? So it has a hook to the class loader. And then the agent gets attached and gets transformed application bytecode as per the agent code. And the class is loaded in the middle. Why am I talking about instrumentation here right now? Because the whole concept with Jmockit work is Jmockit is working as an agent and it is doing something to your bytecode because of which those APIs were, which we discussed about. We discussed about two APIs here in my code. And those APIs are here, real calculator, this one, right, expectations. So you are telling me that in this method, whenever the my calculator starts working, it has to intercept the actual my calculator and replace it by my mock methods. How is this possible? This is possible because Jmockit is acting as an agent and doing something in the background, which is known as instrumentation. That's the way instrumentation works. But you have to observe that we can make instrumentation work by two ways. One is with a Java agent, and we can do an offline instrumentation also. So in my next episode, we will deal with this example with offline instrumentation and make it work. So for now, this is fine. If you like my episode, please click the like button. Thank you.